All right, so I'm going to go to 0. I'm going to go to 0 degrees. Now, it's negative 2, so actually I'm going to go to which way? Towards what? 180. I'm going to let this be coordinate E. Number 4. I'm going to find 5 pi over 3 first. That's in quad 4. Okay? But your R is negative, so are you going to be in quad 4 or quad 2? So you go find the pi over 3 family member in quad 2, which is 2 pi over 3. And there you go. I'm going to let that be F. All right, number 6, negative 2 pi. Okay? Pi is here, but since it's negative 2, it's going to be going toward which angle? 0 degrees. Number 8, negative 2 comma 135. Okay? 135 is right here. It's the pi over 4 family, but it's a negative 2, so it's actually in what quadrant? 4. I'm going to let that be H. Are there any questions on that? All right, now it says convert the given polar to rectangular. Like I said, read your direction. It tells you what to do. So we're going from polar to rectangular. So in rectangular, I need a what? X and a Y, okay? So I need an X and a Y. I'm going to write it on this paper so we can see it better. So we have negative 2 and 0. And I need a formula that gives me the X coordinate and the Y coordinate. X equals what? Cosine theta, and Y equals? Very good. Cosine of 0 is 1. Negative 2 times sine of 0, which is? You get negative 2, 0. So, Ms. Chester, it ended up being the same thing. Yes, sometimes it does. But it means two different things. But it looks the same. Number 12. Negative 1, negative pi over 3. So x equals negative 1 times the cosine of negative pi over 3. Y equals negative 1 times the sine of negative pi over 3. Cosine of negative pi over 3. What's pi over 3 at? Negative pi over 3 at? 4. Your cosine positive or negative? Positive. Positive what? 1/2. Everybody needs to be responding. I gave you all day off yesterday because the time changed. We need to be back on regular ways. Sine of negative pi over 3. What is that? Everybody. Thank you for that energy. I needed that. All right, here we go. That's what I'm talking about. All right, now, my ordered pair would be negative 1/2 root 3 over 2. Did everybody get that? Did I mess up somewhere? Okay. All right, number 14. Now we're going to convert from given rectangular to polar. From rectangular to polar. So if I'm going from rectangular to polar, I need what? I need a R and a what? Okay, so first of all, let's talk about this. Is on one of those major axes, isn't it? So just remember that. Okay, so here we go. We'll find our R. Of course, that's going to be 3, isn't it? Let's think about this. On the coordinate graph, 3 zeros are here, isn't it? Yeah. What angle is over here? So it's going to be 3 zeros. It's going to look just like what it did. Now, if it would have said negative 3 0, because over here you would have used pi. Does that make sense? Because it's in the same location. Is everybody good with that? Because your tangent here is... And at 0, you get a tangent of 0. All right, number 16. Negative 3, negative 3. R equals negative 3 squared plus... Okay, thank you. All right. That's going to be 9 plus 9, which is square root of 18. R equals what? 3 square root of 2. Miss Sister, if I ever had a graph on the polar plane, what ring would that be? Well, you have to estimate. You have to say 3 times square root of 2 be like 4 point something. You just have to estimate. All right. Now tangent of theta. It's going to be 3 divided by negative 3, which is tangent of theta equals negative 1. Now go back to the original. What quadrant is that in? 2. What family are we dealing with that gives me a tangent of negative 1? Power 4. What power 4 family members in quad 2? There's your answer. All right. Number 18. So R equals square root of negative 2 squared plus negative 2 root 3 squared. Negative 2 squared is 4. Negative 2 squared is 4. 4 times, what happens to that square root? So 4 times 3 is what? So R equals square root of 16, which is 4. Now, what quadrant is 18 in? 3. So we need to remember that. So I got a 4. Now I'm going to find tangent of theta equals negative 2 root 3 over negative 2. What happens here? Which family gives me a tangent value of root 3? What pi over 3 is in quad 3? That's your answer. Are we good on that? Okay, we're going to save the rest of homework after we take our quiz. Y'all may start as you get it. You got about 12 minutes on it. You label your points when you graph them, okay? It makes it easy for me to grade. Please. Good morning. just turn that over. Maybe about 3 more minutes on this. Bless you.
Alright, for the ones still working, you still keep it working. For everybody else is finishing group, when one person collect them and bring them to me, if you're still working, you can finish it up. But I'm about to finish going over homework. So for the ones that are done, please get your homework back out. Alright, let's look at this homework here, the last 6 of our homework. Now this dealt with the learning targets of converting equations. Alright, so number 40. Number 40. What type of equation is that, guys? Up here is number 40. What type of equation is number 40? Rectangular. How do you know it's rectangular? It has a y in it. Very good. Now, that means I want to convert this to polar. What formula can I easily substitute in for y to get it not to be rectangular anymore? R sine theta. Very good, because y is equal to that value. Now on these, you want what to be by itself? So I'm going to divide both sides by sine. When I put sine in the denominator like that, I can rewrite it as r equals negative 3 what? Cosecant. Very good. Number 42. The x squared plus y squared is what makes it rectangular. What can I substitute in for that? R squared. R squared. Very good. Do I want to leave it r squared equals 16 or make it just r? Make it. So I'm going to take the square root. When you take the square root of something, you put plus or. Very good. Those are pretty easy when you go from rectangular to polar. Now we're going to go from polar to rectangular. That means what needs to disappear? R and theta. Very good. It has to at least have an x, y, or both of them in there. Now, what's keeping me from doing something right now? What is missing on the side with sine theta? R. Can I put an R there? Yes, but if you multiply that side by R, you've got to multiply the other side by what? R. So that's going to be R squared equals 6R sine theta. Now what can I replace R squared with? And R sine theta can be what? 6y. And that's your answer. X squared plus y squared equals 6y. Alright? Great job now. Number 46. What's keeping keeping us from doing anything right now with that r? It's not r what? Squared. So how can I make that r squared? Square both sides, couldn't I? Because you don't need to multiply both sides by r because you had 8r there, wouldn't you? So you just need to square both sides. So this is going to be r squared equals 64. And replace r squared with x squared plus y squared equals 64. Number 48. When we have the theta, we talked about this one yesterday. What do we need to do? Take the tangent of both sides, because when you do that, you can rewrite the definition of tangents. Y divided by x. What's tangent pi over 4? Then cross what? And y equals x would be my answer. Number 50. What's keeping you from doing anything right now? R is not what? So I'm going to square both sides. R squared equals 100. And replace r squared with x squared plus y squared equals 100. How do y'all feel so far in this unit? Y'all feel okay? I need a hand signal.
So wait, 48 you would do y equals x.
Y over x equals 1 because you replace the definition of tangent.
What's the final answer for that?
Y equals x. Now, what we're about to start today, this learning target, we're going to be on it for 3 days. And it's graphing polar equation. You know, there's always a graphing component. Okay. Let's look over here. Turn to page 5 in your notebook. We're going to learn 1, 2, 3, 6 different types of shapes in this polar equation. You got to be out here. Thank you. You're going to have to be able to know what's about to happen before you graph these. So we're going to spend 3 days. I don't know how long it will take us. How many we're going to do a day, but we're just going to start them. Hopefully to do 3 today. All right, the first one we're going to start off with, guys, on page 5. The shape that it graphs is a circle, okay? And let's talk about how would you know that, okay? If you look at the format here, it's plus or minus a number times a trig function, sine or cosine. Do you see that? Is there any plus or minuses in those formats? Besides, I'm talking about like if you're adding or subtracting. Not the plus or minus itself, but do you see any adding, subtracting like this up there? No. So you need to know there won't be any adding and subtracting. You would see a plus or minus, but not anything like this. Does everybody understand that? So that's the format. For example, you're going to see like r equals 3 times sine theta, r equals negative 2 cosine theta. So when it's in that format, it's going to produce a circle. Okay? Now, I want you to notice something. I drew a rough sketch here. These are not the exact. But where do you notice the sine is going? Is it got a horizontal orientation or a vertical orientation?
Vertical.
And sine is usually associated with which coordinate, x or y? That's why it has a vertical orientation. Cosine looks like a which orientation? So it's around the what axis? Does that make... You see how everything starts relating in trig? Yes. Now, it's positive, it's going to be up. It's negative, it's going to be down. If it's negative, it's going to be to the left. Positive, it's going to be to the right. It starts becoming beautiful, don't it? Look at that. So that's what we're about to graph right now, okay? We're going to graph the circles. So, looking on page 5, looking at the format, you see 4 sine theta and negative 3 cosine theta. Well, there's no plus or minus. It's a number times a function. So these are your circles, okay? All right, you're going to have to make a table for every one of these. So I'm just going to go and tell you, in your table, it's going to be in the format r theta because that is your ordered pairs, okay? You always have your r come first and then your theta. But we're only graphing the major points on the unit circle. So what's my first major point? 0, then what? Oh. Okay, now this is something Miss Fisher messed up on that. It's 0 and r are theta. Theta. So normally we put our input values on this side, don't we? It's going to be backwards on these, okay? So it's going to be 0, pi over 2, pi, 3 pi over 2,
and 2 pi. So your input values go here. You're trying to find your R. So just remember that. That's how these functions are different from all the other types we learn. Normally put on the left and find the right, but this is backwards. All right, so now you're going to plug each one of those in there. What is sine of 0? 0. 0 times 4 is 0. Sine of pi over 2 is 1 times 4 is. Sine of pi is times 4 is 0. Sine of 3 pi over 2 is negative 1 times 4 is. Sine of 2 pi is 0 times. These will always be the same spot, guys. These will always, because you're going to end up back where you started, okay? Now, we're going to graph these. Start at 0. 0, that's at the pole. 4 pi over 2. Pi over 2, go to the fourth ring. 0 pi. I'm still at the what? Pole, aren't I? Negative 4, 3 pi over 2. That would be right where I'm at, right there, wouldn't it? So guess what you do? That's your answer. That's all you do. Draw a circle. Let's do the next one. Use some misgesture. These are real easy, yeah. That's why I start off with these self-esteem boosters right here. Because when we do roses and flower petals, these are self-esteem boosters right here. Alright. Cosine of 0 is what? 1 times negative 3 is. Cosine of pi over 2 is 0 times anything, 0. Cosine of pi. Cosine of pi is negative 1 times negative 3 is. Cosine of 3 pi over 2 is 0. And then this back at. So I want to graph negative 3 comma 0. I find 0, but since it's a negative 3, am I going toward 0 or toward 180? 180. 0 pi over 2 would be at the what? Pole. 3 pi is the same location. 0, 3 pi is the same location, okay? So you just draw a circle. And there's your graph. You never know how many points you got. Sometimes you might just have 2. Some you might have 4. It just depends. But there's your circle. Circles usually just have 2. Are there any questions on the format of circles? Now, we're about to study the big family. What do you think that word is? Lamesons. Say Lamesons. Lamesons. Say Lamesons again. I know, I don't know. Yes. I thought it was Lamacons, but it's pronounced Lamesons. Lamesons. Okay. There's 3 types of Lamesons. No, I wasn't after we study now. Oh, it gets even better after this unit. Lamesons. You have 3 types of lamesons. You have one that has a swirl. You have one that has a dimple at the origin, and then you have the third one that just has a dimple somewhere. So those are 3 types. We have a lamesson that has a swirl, a lamesson that has a dimple at the origin, and a lamesson that has just a dimple somewhere. Okay. So what we're going to study first is the lamesson that has the swirl. And let's look up here. What makes it a swirl? You see how that little swirl right there? That's what I mean by swirl. It's got a little swirl. It goes in. A little indentation. If your A is less than B, this type of lamesson has a swirl. And I want you to think absolute value. The absolute value of A is less than the absolute value of B. Okay? For example, here's an example. First of all, lamessons, all lamesson family, they're the only ones that have plus or minus in there. So that's one characteristic. They all have either plus or minuses. Now, this is what it tells you. The A and B value tells you what type, okay? What's the absolute value of 1? What's the absolute value of 3? Is 1 less than 3? This is going to have a swirl. What's the absolute value of 1? Absolute value negative 4?
What, does one have a lesser?
Yes.
Do you see how these you would know will have a swirl? Does everybody see that? Okay, so let's try it. We're still going to graph the major points, okay? Now, because we do the major points, most times we do this computation together, okay? What is 3 times the sine of 0? What's sine of 0? 0. 0 times 3 is? Plus 1 is? Thank you. What is sine of pi over 2? 1 times 3 is? Plus 1 is? What is sine of pi? What is it? 0. 0 times 3 is? Plus 1 is? Sine of 3 pi over 2? Negative 1 times 3 is? Negative 3 plus 1 is? Sine of 2 pi is? 0 times 3 is? Plus 1 is? So shouldn't these be the same, the first and beginning? Yes. Now, could you imagine? Okay, now you realize why we did Treaty Tuesday first week of August. Could you imagine getting to this semester and having to learn all this and do all this, just barely knowing it? You'll be a situation with it. Yes, that's why we put so much emphasis on Treaty Tuesday. All right, so let's graph this. 1, 0. Go to 0, go out to the first ring. Locate pi over 2, go up to the fourth ring. Locate pi, go out to the first ring. 3 pi over 2, but it's negative 2, so you're going to go toward pi over 2. And then 1, 2 pi is back there. Okay. Now, guess what your graphing calculator graphs is? But I'm going to show you that tomorrow. You can do it. You can check your work on your graphing calculator. You have to put it in polar form, and make sure your calculator is in radians, and it graphs all these. I want to show you that tomorrow, okay? All right. Now, when you're connecting the dots, you have to go from your first to last. You can't just start with a dot and go, okay? So 1, 0. So I'm going to start here. Watch this. And I know that there's an inner swirl. You just make your little inner swirl and make sure you go through that button, and that's your graph. You said, Mr. Esther, how do I know where to do it? You just got to make a swirl and go through that point. We're just sketching the graph, okay? On number 4, do you see that the absolute value of 1 is less than the absolute value of negative 4? That's why we have a swirl. What's cosine of 0? 1. 1 minus 4 is what? Negative 3. Do you see that? Hold on. Cosine of 0 is 1. 1 times negative 4 is what? Negative 4 and 1 gives you negative 3. Cosine of pi over 2 is 0, so that goes out, leaves you 1. Cosine of pi is negative 1. Negative 1 times negative 4 is what? 4 and 1 gives you 5. Cosine of 3 pi over 2 is 0, so that goes away, just leaves you 1. Cosine of 2 pi is 1. 1 times negative 4 is negative 4, plus 1 is negative 3. That should always equal that to begin with. Alright. Negative 3, 0. Okay. I'm going to go to 0. I'm going to go backwards to 180. 1 up to pi over 2. Go toward pi. That's 1, 2, 3, 4, 5. Okay. Got my 4 dots there. So I'm going to start here.
And there's my graph.
No, we do not do domain and range with none of this. Yes.
So you're not necessarily graphing them with what order you put them on the graph. You're just graphing.
No, you graph them in order.
Okay.
I started with this one. And okay, so you said, Mr. How do you know which one's going to have the swirl in? It's always the one indented in. You see what I'm saying? The other three are not going to. So I need to start here and just come around, and I know that my swirl's going to be there. Does everybody see that? Okay, we're going to stop there for today and pick up on the Lamson family tomorrow.
You're going to need graphs for your homework, so I'm going to give everybody